In our previous lesson, we saw how we can read input and print output using scanf and printf, and we also wrote a basic program to find product of two numbers. Now in this lesson, we will see in detail how we can use various arithmetic operators to perform calculations in our program. Let's get started by writing some code. I have already written a couple of lines here. First line at the top, is a comment. A comment is ignored by the compiler. It's not treated as an instruction to be executed. To write a comment in a single line in C, we need to type in 2 forward slashes, and anything starting the forward slashes till the end of that line would be a comment. In the next line, I have written an instruction to include stdio.h library. This library gives us some basic functionalities. Printf and scanf are part of this library. And after that, I'm writing my main function. Now in my main function here, what I want to do is I want to declare two integer variables named a and b, and I want to ask the user to input these two integers. So I'm first printing a message on screen, enter a, and then I'm using scanf to receive input in a. And just like a, I'll receive another integer value in b. And now let's do some maths here. I first want to calculate sum of a and b, so I'll declare an integer variable named sum, and after I've got a and b as input, I'll say sum equal a plus b, and with this instruction I've calculated sum of values in a and b, and I've assigned it to this variable named sum. And now I want to write a printf to say a plus b equal whatever the sum is. Now next I want to calculate a minus b. I have declared a variable named diff, and I'm saying diff equal a minus b, and once again I'll write a printf. So this is my difference. Next I want to calculate the product of a and b. I'm multiplying a and b with this expression a asterisk b. Asterisk is the symbol for multiplication operator, and I'm storing the value in this variable named product. So with this much of code, we have asked the user to enter two numbers a and b, and then we are calculating and printing a plus b, a minus b, and a into b. Let's quickly run this program and see what will happen. The program is asking me to enter a. Let's say a is equal to 10. Now it's asking to enter b. Let's say b is equal to 5. And now we have got some output here. As we can see, output of all the three printfs has come on a single line. This is happening because printf by default does not take the cursor to the next line. We need to explicitly insert an end of line character to take the cursor to the next line. What I'll do here is, at the end of the string constants in each of these printfs, I'll type in backslash and then n. Backslash and n together is treated as a single character. Backslash n is called end of line character. For a backslash n, an end of line character will be printed and cursor will go to the next line. So I'll put backslash n in all three printfs. And now when I'm running this program, output of each printf is coming on a separate line. In the first printf, %d in the string constant will be replaced with value in sum, and that's why we have a plus b equal 15 printed here. 10 plus 5 is 15, and similarly a minus b, that would be 10 minus 5 is 5, and a into b is 50. End of line character, which is also called new line character or line break, should be interpreted more like a command to be executed rather than as data. It's inserted in data, but it works like a command. It takes all the text following it to a new line. Okay, so with this much of code, we are performing addition, subtraction, and multiplication. Let's now perform division. Let's say we want to divide a by b. If I'm dividing a by b, then a may not be completely divisible by b. b may not be a factor of a. In such a case, we can show the result, the outcome of division, in two ways. We can either show result as a real number. For example, if I'm dividing 9 by 2, then the result would be 4.5. There would be a fractional part. Or what we can do is we can say that quotient of this division is this and remainder is this. Quotient is basically the integral part of the result of a division. To perform division in my code here, I can use division operator. I'll declare a variable named C here, and I'll write a statement C equal A by B. / is my division operator. And now I'll print this value. I've written a printf A by B equal whatever is assigned to C after division. Let's quickly run this and see the output. This time I want to say A is equal to 9 and B is equal to 2. What I'm getting here is A by B equal 4. We are getting the quotient. This is happening because A and B both are of type integer. We have declared them as int. And when division operator is applied to two integers, then only the integral part or the quotient is returned back. If you want the fractional part as well, then you need to declare A and B as variables of type float or double. Float and double are types that are used to store and perform calculations on real numbers. What I'll do now is, in the declaration statement, I'll change this int to float. So now all my variables are of type float. Now in all the scanf and printf statements, the format string or the string constant should have placeholder %f instead of %d. %f is placeholder for float. Let's run this program now. Once again I'll say A equal 9 and B equal to 2 and see what we have got here. Data is being printed with fractional part. By default, printf is printing 6 digits after the decimal point. We can choose to print as many as we want. Let's say I want to print only 2 digits after the decimal point. Then instead of writing %f in my string constant as placeholder, I'll write .2f, %.2f. And now only 2 most significant digits after the decimal point will be printed. If I want 3, I'll say .3f. Let's just put .2f everywhere in all the printfs. And let's run the program now. Once again, let's say A is equal to 9. And now because we are scanning a floating point number, a real number, we can also enter something like 9.0. I can have a fractional part in my input as well. Now let's say B is equal to 2. It's not mandatory to enter the fractional part if it's 0, and this is what I'm getting. All the values are being printed till 2 digits after decimal point. There is another data type that can be used to store real numbers, and it's called double. So instead of using float here, we could use double. With double, you get twice the memory or storage as compared to float. In a typical architecture, size of float would be 4 bytes or 32 bits, and size of double would be 8 bytes or 64 bits. If my variables are of type double, then I need to use %lf as placeholder in these format strings passed to printf and scanf. Okay, now I want to come back to integers, and I want to talk about one more operator. And this operator is called modulus operator. As we had seen earlier, division with integer types gives us the quotient. I'll rename this variable C as quotient. And now I want to declare another variable named remainder. Modulus operator gives us the remainder. Symbol for modulus operator is this character, this %sign. With this statement, remainder equal A modulo B, we will get the remainder of division of A by B. I'll just print the remainder. Let's run this program and see what happens now. I'll say A is equal to 9 and B is equal to 2, and this is what I've got. In the last line, I have got 1. If I'll divide 9 by 2, remainder would be 1. I'm writing the value only. I'm not writing something like A modulo B equal this. Actually, let's just print this like all other lines. In this last printf now, I'm writing A %B equal %D. %D is my placeholder. Now when I'm running this program, I have not got the %sign here in the output of last printf. This is happening because % is treated as a special character by printf. It's treated as beginning of a placeholder. To print this character using printf, what we need to do is we need to put 2% together. if we will put 2% together, printf will not look at the pair in context of a placeholder. As you can see, now we have got the output a% b equal 1, or we should say a modulo b equal 1. Okay, so now we know how to do some basic arithmetic in C. We can write an arithmetic expression and assign it to a variable. Once the expression is evaluated, result will be stored in this variable. In this statement, sum equal a plus b, this equal to sign is for assignment operator. In right hand side of assignment operator, we have an arithmetic expression, and in left of this assignment operator we have a variable name. We cannot have anything else in left of an assignment operator. It must always be a variable. In right we can have a constant, a variable, or an expression. Here we have an arithmetic expression, and we have a really simple arithmetic expression here. We could have a really complex one with multiple constants, variables, and operators. I have written some more instructions here, and in all these instructions we have arithmetic expression with more than one operator. We can write such complex arithmetic expressions, but we must understand how to create syntactically correct expressions in code, and we must also understand how these expressions will get evaluated. We have discussed these 5 arithmetic operators. All of these are binary operators. An operator that operates upon 2 operands is called a binary operator. Operand by definition is an object on which operation is being performed. For all these operators, we must have an operand in left and another operand in right, and the operator itself would be in between. Operand can be a constant, a variable, or in a complex expression, operand can be an expression itself. Let's pick this expression a plus 2 into b. We have 2 operators here. We have addition and we have multiplication. Now can you tell me the operands for each of these 2 operators? Well, it will depend upon which operation we are performing first. If we are performing the addition first, then for addition operands are a and 2, and for multiplication operands are a plus 2 and b. But if we are performing the multiplication first, then operands for multiplication would be 2 and b, and operands for addition would be a and this expression 2 into b. If you remember your high school mathematics, then precedence or priority of multiplication and division operations is higher than that of addition and subtraction, and so in this expression multiplication will be performed first. So this is correct interpretation and this is incorrect. In a complex expression, operator precedence is applied to decide the order of operations. In an arithmetic expression, first preference is given to parenthesis. Next in priority or preference are multiplication, division, and modulo, and then come addition and subtraction. If there are 2 operators of same priority, then they are executed from left to right. By this expression a plus 2 into b, what we implicitly mean is a plus and then 2 into b within parentheses. If we want the addition to be performed first, then we must put parentheses explicitly. We should actually write expression like this. Now I have come back to this code that I had written earlier. What I'm doing here is that I'm assigning these expressions to variables. What we can also do is that we can pass these expressions directly as function arguments. So in the first printf, instead of passing sum, I can directly pass a plus b, so I don't need this variable named sum. And similarly in the next printf, I can simply pass a minus b. In the next I can pass a into b. For the quotient I can pass a by b, and for modulus we can pass a modulo b. If you'll run this program, you'll get the same output as earlier. So an arithmetic expression can be assigned to a variable, or it can be passed directly as argument to a function. Okay, now what I want to do next is I want to erase all the code in this main function, and now I want to write some arithmetic expressions and I want you to guess the output. What do you think will be the output of this program? Give this some time and deduce the answer. In this expression a plus b by 2, we have two operators, addition and division, and we have no parenthesis, so division will be performed first. B is 3 and 3 by 2 will give us 1. Remember, when we divide an integer by another, we get the quotient or the integral part. So b by 2 would be 1 and a is 4, so c would be 4 plus 1, that is 5. When I'm running the program, as you can see, I've got 5. Now, what should be the output of this one? We have two operators, subtraction and addition. They have equal priority, so they will be executed from left to right. A minus b would be 4 minus 3, that is 1, and c is 6, so 1 plus 6 would be 7. D would be 7. Okay, now what should be the output of this one? Part of the expression within parentheses will be executed first. A plus b would be 7, c minus d would be 1, so e would be 7 into 1, that is 7. And my guess is right again. So with this much, I hope you got some understanding of how you can perform arithmetic operations in your code. I'll stop here now. This is it in this lesson on arithmetic operators. Thanks for watching.